Hello friends, in this video, let us learn how to perform binary search using divide and conquer algorithm. So we have already learned binary search using the normal method. If you're unfamiliar with the binary search concept, you can watch the binary search video under the searching algorithms section. In this video, let us learn how to solve the binary search with a divide and conquer algorithm. So in the normal approach, whenever the middle element is not matching, we will change the start and end index accordingly. In this approach, if the middle element is not matching, we will divide the respective subarray and continue the same process using recursion. Let us see how. Let us take a sorted array of 8 elements: 10, 23, 45, 70, 90, 100, 111, 123. And indices start from 0 to 7. So start is equal to 0 and end is equal to 7. And remember, the array should be sorted in order to apply the binary search algorithm. And let us assume the key to be found is 45. So what will binary search algorithm do? It will calculate the middle index, and if the middle index matches the key, the search is found. Otherwise, it will skip on the subarray and do the same process until it finds the element. Here, the start index is 0 and end index is 7. So middle index will be 0 plus 7 divided by 2, which is 3. So check if index 3 has the value 45. And it is not. Index 3 has the value 70. And since the array is in sorted order, the key 45 should be present before index 3. So the divide and conquer algorithm will divide the subarray from index 0 to 2 and do the same process. Here, mid is equal to 0 plus 2 divided by 2, which is 1. So the middle index is equal to 1. So check if it has the value 45, but it has the value 23. And since 45 is greater than 23, if 45 is present in the array, it should be present in the right subarray only. That is after 23. So the divide and conquer algorithm will divide the subarray where the starting and ending is 2. Now the mid index is equal to 2 plus 2 divided by 2, which is 2. And index 2 has the value 45, which means our search is found. So let us see the code for binary search function and explain it using the same case. So here we have the binary search function, and we will pass the array, start of the array, end of the array, and the key to be searched into the function. So here this is the array. Its start is equal to 0, end is equal to 7, and the key to be searched is 45. So we have to find the middle element. Check if it is the key, else find where the key can be present and divide the array and search in one subarray only. So we have to do this process till we find the key or we get an invalid index. So put the code inside this if start less than or equal to end. And find mid first, that is start plus end by 2. That is 7 by 2, which is equal to 3. So check if element at index is the key 45, and it is not. So check if this middle element is less than the key, and it is not. So 45 can only be present in the left part. So we have written binary search of array start 0, mid minus 1, that is 2, and key 45. So from binary search function, we are calling binary search with the same array, start as 0 and end as 2. Let us say this is binary search 1. And whatever this function binary search 1 is returning, that value will be returned by this main binary search also. So let us see what happens here. Here, start is less than end. So find mid, and it will be 2 by 2 equal to 1. So check if element at index 1 is the key, and it is not. So check if this middle element is less than key, and it is. So 45 can only be present in the right part of this subarray. So we are calling binary search again. So we have binary search of ARR start as mid plus 1 which is 2 and end as 2 and key 45. So let us call this as binary search 2. So we had main binary search calling binary search 1 and binary search 1 is calling binary search 2. So let us see what happens in binary search 2. Here start is equal to end. So find mid which is 2 plus 2 divided by 2 equal to 2. So check if element at middle index 2 is the key and it is. So return 1 as the search is found. So binary search 2 is returning 1 to binary search 1 and binary search 1 is returning 1 to this main binary search function. And finally, this function will return the result 1 to main function. So this is how we implement binary search using divide and conquer approach. So what were the 3 steps in divide and conquer approach? Divide, conquer and combine. Here, splitting the sub-array is equal to dividing the problem. Finding the middle index and checking whether it has the key or solution is conquering the problem. And returning search found status, that is the result, from various recursive calls is known as combining. So this is a perfect example of the divide and conquer algorithm. This is how the divide and conquer algorithm recursively divide the original array and search the given key, and finally the result is gathered from those recursive calls.